Welcome to Spring LIB.
Okay, so the first three parts of this problem is more mathematics than physics. So part A, we're given ds equals r d theta. We're required to find s. So we just integrate both sides. Then s equals integration of r d theta. R theta is given. So upon integration over theta, this is simply r0 theta plus 1/2 beta theta squared. For part B, we fix that s equals vt, and using s equals this above equation, we combine these two. We see this is just an equation for theta, so we can solve for it to get two roots. One is positive, the other is negative. Of course, we choose the positive one because it has the correct physical meaning. A negative theta would mean that the direction of rotation is in the opposite direction. Okay. Then the expression for theta is this. For part C, the angular velocity is the time derivative of theta. So direct computation gives us this expression, v over square root r0 squared plus 2 beta vt. And angular acceleration is another time derivative of angular velocity, which is negative beta v squared over r0 squared plus 2 beta vt to the 3/2. Okay. And then for the fourth part of the problem, part D, we're given r0 equals 25 millimeters. We're given after one revolution, the radius changes. So r theta plus 2 pi minus r theta, that is the radius change in one revolution. This is given equal to 1.55 millimeters. So if you plug in the expression for r, we'll see that r theta plus 2 pi minus r theta is simply 2 pi beta. From this, we can solve for beta, which in terms of standard units is 0.247 times 10 to the negative 6 meter radian. And we're also given the time 74 minutes, or equivalently 4440 seconds. So plugging all this, so plugging beta, t, and r0 into the expression of theta. So we plug in beta, t, and r0. V is also given. So everything is known. We can safely find theta to be 1.337 times 10 to the 5 radian, or in terms of revolutions is 2.13 times 10 to the 4 revolution. Okay, in the last part of the problem, we simply plug in again the numbers for beta, t, r0, v to the previous expressions for omega and alpha. You can draw it using mathematical or even by hand. Omega t looks like this shape, while the alpha t looks more like this. Okay.